So let me begin this talk. This talk is about having consistent AI performance in the hybrid cloud. So let me begin by doing a small survey. How many of you think that running AI solutions in the enterprise at the enterprise level is difficult? Oh, so a lot of people think it's quite easy. Anyway, so in this talk we are going to talk about how to make things simpler so that we can move easily. So this talk is all about presenting something that Cisco is doing in the open source community so that we can move seamlessly from AI science to AI engineering. Now what do I mean by AI science? AI science is most of the time data scientists are able to work out solutions to analytics problems or AI problems on their laptops, but when it has to move to enterprise or when it has to run on an enterprise grade cluster, it's not that easy because the problems there are no longer AI related, it's mostly a systems issue. So training, inferring, these things run on a large number of machines, which usually the data scientist has no idea how to manage. So we at Cisco are working on this open source project called Kubeflow, which the entire purpose is to make your science projects become engineering solutions. So the agenda of today's talk is that I will briefly introduce what the problem is, then what is the solution that we are talking about, then we will go into a demo, and I hope the demo gods are with me. I'll briefly talk about what Cisco's contributions are, and then what are next steps that both we in Cisco have to do and what I would expect people from the audience to do. So before I go into the problem, let me introduce myself. My name is Amit. I am a principal engineer at the Cloud CTO office. And these days I'm working on making AI solutions simpler to port from your lab to the enterprise. I don't think this thing works very well. So as I said, what is the main problem here, right? We have this problem of having solutions to AI science problems where a few people can run it, but once we move into the enterprise grade, things are not that easy. How do you make things run on a large scale system? So the perception of AI problems are like this, that there is a huge piece of machine learning code and a lot of peripheral activities which have to be done. The peripheral activities include data collection, data verification, serving infrastructure, monitoring of your infrastructure, and process management, a lot of different kind of things, which typically are considered to be in the realm of this thing is not working. Anyway. But in reality, what happens is that the machine learning code is actually pretty small and very straightforward. Most people don't write new machine learning code these days. If you want a cat versus dog classifier, you can get tons of code from the web. Download it, run it. Most people who have had some coding experience can do it in under an hour. It's not a big problem at all. However, it's the other part, the parts here in blue, which are the real problem, which is how do you extract data, how do you clean data. Nope. I don't think it's working. So how do you clean data? What are your analysis tools? What is the serving infrastructure? All the things in blue are really, really difficult to do. And this should smell of something that everybody knows. There is a lot of DevOps that is involved in actually making this thing run. So, and who is good at DevOps? The current day, there is only kind of one solution which has proven DevOps applicability in the real world, which is based on Kubernetes. So from this talk, if you have to take away anything, you can forget the rest of the talk, but this is the message that we are trying to pass here. Kubeflow is a project which enables you to go from AI science to AI engineering in a multi-cloud world. So it doesn't have to be a single cloud. You can go from on-premise to cloud, from one cloud to another cloud, from one on-premise installation to another on-premise installation. All that you need for your AI solutions to work is a Kubernetes cluster underneath. So Kubeflow runs on top of Kubernetes, which is kind of the de facto standard for container-based orchestration. So when we talk about building something which works across cloud, across platforms, there are a few choices we can make, right? The first choice is what kind of tools do we need to use? What DevSecOps do we want to use? Should we use Kubernetes? Should we use Docker? Should we use OpenShift? Should we use something else? What tool chains to use? Most people use either TensorFlow or PyTorch, but there are still quite a few other options available to you, right? And then finally, how do you manage the data? You won't run an AI experiment only once. You will run it multiple times with changing data. Your performance will change. You will have certain models working better than other models. How do you keep track of all those things, right? There might be a particular model with a particular set of parameters which work very well for, say, object classification, say, car classification, right? And there might be the same model with a different set of parameters which work well for face recognition, right? You need to keep track of all these things. It's not a trivial problem. So at Cisco and through the Kubeflow project, our bet has been to select a few options. It's not that these are the only options possible. As I said, there are multiple possibilities. But for the DevSecOps tools, we use Kubernetes because that's kind of the de facto standard these days. If you choose anything else, there's a lot of explaining to do. Kubernetes works well. The community is very large, and we all know that it's been accepted by the community. Then what are the ML tools ML tool chains to pick? Here we keep it reasonably wide. What we do is that we say, okay, we'll allow TensorFlow, which is by far the most commonly used. We'll also have compatibility with PyTorch and with Caffe. And the architecture of Kubeflow is such that there is actually no vendor lock-in. Any toolkit can easily be ported over to Kubeflow. So that means that your data scientists can run their experiments in their preferred language, in their preferred toolkit, and you would not have to worry about how to migrate that into an enterprise-grade production. You would not have to rewrite a TensorFlow code into PyTorch or a PyTorch code into Caffe or anything of that sort. And finally, what we need is a machine learning lifecycle manager. What do I mean by that is how do you take different parts of the process and like a pipeline of steps that you need to do for any machine learning project and stitch them all together and make it easy. Is this working?
It's the adapter then, because it's not working with this.
Okay. Why don't we use that? It's fine.
The other way?
Yeah.
Let's try. No, it's the videos.
Is this working? This is working. Okay. Okay, sorry about that. And the other important thing that we wanted to go with from a Cisco point of view is that we wanted the entire solution to be open source. We did not want any Cisco proprietary stuff to go into this, because even within Cisco, we have so many people working on this that if a particular BU has proprietary stuff, the other BUs cannot contribute to it, cannot manage it, cannot handle it very well. So we decided from the get-go that it will be an entirely open source project. Right? Just a bit of history about Kubeflow. It was started by Google, but again run entirely as an open source project. Anybody can contribute following the rules that the project goes through. So the Kubeflow project is dedicated to making deployments of machine learning workflows on Kubernetes simple, portable, and scalable. So there are, apart from the words in blue, there is one important thing here. It is only designed to run on Kubernetes. You cannot modify it to run on anything else. You can, but that's not the purpose of Kubeflow. It will not run on anything. It will not run on VMs. It will not run on any kind of other container orchestration system. It needs a Kubernetes endpoint. And all it needs is a Kubernetes endpoint. So what are the goals of Kubeflow that it set out to do? It is not to recreate other services, but to provide a straightforward way to deploy best-of-breed open source systems for ML to diverse infrastructure. So the basic idea is anywhere you have Kubernetes, you should be able to run Kubeflow. That's it. That means anywhere you have Kubernetes, you can run your machine learning run your machine learning solutions. And as I already said, it does not plan to work on any other platform. So if you look at an ML platform, this is basically a serialized view of the picture that I had earlier. So what this says is that usually there are a lot of blocks. The blocks include data ingestion, data analysis, transformation, validation, data splitting, and finally the blocks in blue, which are colored in blue specifically because these are the blocks that Kubeflow currently targets. These are all the blocks that Kubeflow supports. So through Kubeflow, you can train your model. From training, you can build your model and validate the model. You can train at scale. You can start serving the model. It doesn't yet talk about rolling out the model in multi-cloud scenario, but those are things that are coming up. Kubeflow, by the way, is not 1.0 yet. It's 0.4. 0.5 is coming up, I think, sometime in March. And by KubeCon this year, we might have 1.0. So the Kubeflow user experience is that the user deploys Kubeflow, and the user runs experiments in a Jupyter notebook. So Kubeflow comes pre-programmed with Jupyter notebooks. And if the user really wants training at scale, which is something you would do for large data sets or for larger experiments, then you go through the blocks in red. So you build a Docker image, and then you train at scale. But for a lot of data science experiments, and even for reasonable size applications, what you need is just to build a model server, because you've trained the model, you have the model parameters, you can build a model server, and you could deploy the model and then start serving from it. So you do not necessarily always need the two boxes that are marked in red. But Kubeflow allows for it anyway. So if you look at the overall Kubeflow stack, it's pretty much straightforward. You have your infrastructure on top of which Kubernetes runs, and Kubeflow just runs on top of Kubernetes. There is no other requirement than to have a Kubernetes endpoint. That's about it. Your Kubeflow installation is only as good as your Kubernetes installation. So before I go into a demo, I would like to pause and ask if there is any questions right now. Yes, please.
Considering integrate also platform services like Jupyter or I think Data Lab in the Google Cloud or TensorFlow existing managed version. Are you also considering to support this kind of thing?
So
Stay on the container?
yeah, so if I'm not mistaken, your question is, are we trying to integrate with the platform services as well, right?
Yeah, exactly.
So
There's quite some tool chain to the cloud.
yeah, so both yes and no, in a sense that it already supports TensorFlow and anything kind of that comes with TensorFlow. Similar story with PyTorch from a machine learning point of view, right? But there is a lot of other integration which are from data lakes. How do you get the actual data in, which is the biggest problem that enterprises have right now. Because data is there in Hadoop databases, data is there in SQL databases, and Kubeflow doesn't directly talk about how to get that data. So that's why many of those yellow boxes are still not done by Kubeflow. We are getting there, but right now we cannot give you a solution inside Kubeflow saying, hey, here is your SQL database. This is, you just use this plugin of Kubeflow and that's, but the open source community is working on it. Did I answer your question?
Thank you. It is just that my feeling is that if you abstract it on the container level, you have the portability, which is a strong argument. On the other side, you cannot use things like TPU and so on. So I guess you are tied
Oh,
to
okay,
the underlying hardware that the
So,
cloud container.
so if there is a way of exposing your TPU via Kubernetes, then yeah, sure you can use. It already works with GPUs, obviously, because Kubernetes can expose GPU. So from that point of view, it's fine. But TPU exactly, I'm not sure. I will give you my card in case you want to send me a question. I will be glad to give you a more detailed information. Any other questions? Okay, we'll move on. So the demo that I'm trying to do two small demos. The first demo is a very basic one. It shows what is, that it's easy to go from your laptop to a cloud installation and run the same experiment. So the demo is pretty straightforward. You have an installation step, which and then there is a train step, which takes the MNIST database, which is nothing but handwritten number recognition. That's the database. And the model is trained. The parameters are stored in a persistent parameter storage. From there is a serving layer which picks up the parameters, and the client basically sends an image. You serve the data. You infer from the stored data from the serving module, and then you give back an answer saying that, okay, this is a 0 or a 1 or something like that. It's one of the most basic experiments that you can do in ML. And underneath, this is the infrastructure for the demo is this. It starts with it runs entirely on Google Kubernetes engine. The next demo that I'll show will run on an UCS server. So this one runs on Google Kubernetes engine and on your own laptop, on a MacBook. So there is a training phase, there is a parameter storage phase, and then there is a serving phase, and you connect to it using your browser. Hopefully this will play. Okay. So if you will, so right now it's just installing the Kubeflow components. It's pretty straightforward. There's nothing much to be done. So what's happening here is, you can't obviously read through it. What's happening here is that we set up a local Kubernetes environment, and that's where we are doing our training. Okay, the entire training will be done. So this is your training code in the Jupyter notebook, and you run the training, and everything is stored in your local Kubernetes environment, right? So there is a model. So now the kubectl config user context becomes cloud. So there is a cloud config, which is nothing but a kube config, which is pointing to GKE. That's about it, right? And once you start sending, the model was trained locally, then the model parameters were updated on the cloud, and now the application is accessing that cloud parameter and using that to infer the digits. So I know the video was very quick because we don't have that much time. So initially, when this app was running, there was no model on the server, on the cloud. So that's what happened. What was happening was it couldn't infer any digits. It was just don't know because there's no model running. But now what happened is, once the model parameters got updated, if you press on a digit, you'll just get an inference out of it. This is a very straightforward. You'll almost get 100% accuracy with that, unless your handwriting is pretty weird. Now I will try to do another demo, which is going to be it's going to be a live demo. So this is a demo based on a problem called bolt classification, which somebody pointed out that this is called bolt classification, but the images there are actually screws. So there is a big difference between screws and bolts for people who are into mechanical engineering. But anyway, we will ignore that for the time being. So it basically trains a classifier for bolt images. So each bolt has a particular type. It deploys the model, and then you can visualize the metrics of the training process. And the purpose of the demo is actually to show, this demo runs on UCS servers, and the purpose of the demo is to show a feature of Kubeflow, which is called Kubeflow pipelines. Now what Kubeflow pipelines allows you to do is kind of diagrammatically draw out your machine learning pipeline, and then make sure, that's what you feed into the system, and that's what runs, right? So I will try to do that demo. You are welcome to go into pipelines and see. There are lots of other demos which are available online. Yeah, there are starting codes available. So So what I'm going to show here while this comes up is, we will show the code which generates a particular graph, which is the pipeline graph, and then we'll show how that graph is loaded onto Kubeflow. And once it's loaded onto Kubeflow, it will run an experiment, and you can analyze how the experiment went, what is its accuracy, what are the error levels, and things like that. Okay, thanks. So here, if you go into Kubeflow pipelines, you basically do a create run, and you choose. So this is the definition of a pipeline. I will show how it looks. So use this pipeline, you change a few parameters. Most of these are default parameters. I think the model directory has to be changed. And oh, okay. Test pipeline. And all you need to do is start. So while it actually goes ahead and does that, what I'm going to show you is what is it actually doing. So this is the graph that I was talking about. This is how the pipeline actually looks. There is a train block, then there is a prediction block, there is a deploy block, there is some model quality checks, there is a tensor board. This is using TensorFlow, by the way. So there is a tensor board which lets you look at the accuracy and the performance of your training, right? Oops. So this is how the code for that pipeline looks like. Basically, it's a container for each of those blocks. That's what this entire code does, right? And you take that piece of code and you run it through and you run it through a DSL compiler, which generates the tarball that I gave, that I uploaded to the pipeline UI, right? And once it runs, this picture is from a run that I did like 10 minutes back. So what this shows is that all the blocks have completed except for TensorBoard, which is continuously running to, it never completes. That's why it shows that it's always running, right? Now, there is also a client code, which is a Jupyter notebook. So you can use your client code to figure out whether it's actually working or not. So this is the client. So if we just run it, okay, that ran. So this is here. We are giving it a particular image, which is of type BXM, and we want to see that it actually returns something with the same type, right? So it actually ran on the generated model. It gave a BXM with a score with a confidence level of 97%, right? So this is just to test that your models are working and things like that, right? in reality, you would probably have a pretty good, UI-based application where you can take pictures of a bolt and send it to this and get your classification done. Similarly, there is another one which classifies as a different bolt. But here, for whatever reason, the accuracy is much lower. It's just 80%, right? Uh-oh. Hopefully this will show up. Oh, okay. So the tensor board module, this was the module. This shows the accuracy of your runs, the cross entropy, which is nothing but the loss of your run. So all the typical model parameters or training parameters that you would use, right? So now, the good thing about this, the advantage that Kubeflow does is, so a lot of people come up with this question, so why do I need Kubeflow? I can do this all, because it's at the end running on Kubernetes, right? I can do this all just by myself. And yeah, sure, you could do it all by yourself. But the point is, tomorrow, if your cluster changes, or if you have suddenly large number of servers, you want to use more GPUs, then you have to do a lot of manual stuff, which is not everybody's cup of tea, right? So it's a lot of work. But if you use Kubeflow, all you need to do is change the kube config at the end of that you point Kubeflow to, and that's all that it takes. You can go from a 10-node Kubernetes cluster to a 1,000-node Kubernetes cluster, ideally with no hiccups at all, right? So before I go into briefly mention what are Cisco's contributions, any further questions? Any questions about the demo? Anything about Kubeflow? Any questions at all? Okay. So I will quickly jump into what has been Cisco's contribution to this. As I said, this project was started by Google, but we work very closely with Google for this project. So the contribution areas that are kind of entirely owned by Cisco has been, the PyTorch support has been done by Cisco. So previously the Kubeflow project started with just TensorFlow support, but now Kubeflow supports PyTorch as well. So that entire support was done by our team. There is also a KubeBench, which is part of Kubeflow. What does KubeBench do? It's there to benchmark ML workloads. Still, today there were no standard way of benchmarking ML workloads. So for example, if you want to do cat versus dog classification, how long does it take for you to train given a particular setup? There was no easy way to do that experiment. You would have to do the experiment manually and everything, right? With KubeBench, you can, whatever code we were using in that pipeline, we can simply run that in your benchmark in KubeBench, and it will give you data about, hey, this is how long it took, and your previous say UCS box took longer or shorter, whatever, right? You can benchmark all your experiments, which is something very useful, especially for a company like Cisco, because we want to go and showcase our UCS boxes and say, hey, this works better than a previous version or compared to some other box, right? A competitor's box. There is a lot of work going on hyperparameter optimization. Now, what do I mean by hyperparameter optimization? Every machine learning model has a lot of parameters to be tuned, and it can be a very tedious process if the parameters have to be tuned manually. So the hyperparameter optimization is nothing but automatic tuning of those parameters. So that is also, it's a hot new research field even in the machine learning community, but it's also already coming into Kubeflow. And there is a lot of product management participation from within our team, from UCS. There is Google and Cisco are doing joint demos in the world of solutions. So these are just you will have the slides. You are free to reach out to any of them to get more information about Kubeflow. So what next? So we have talked about the whole agenda, right? We have given the problem, which is that the systems issue in machine learning solutions is not easy. Going from AI science to AI engineering is difficult. And we have presented our solution, which is the open source project called Kubeflow, which helps you to move very quickly from any Kubernetes cluster to any Kubernetes cluster, thus making your science to engineering transition better. I showed you a couple of demos, and then I listed out what are Cisco's contributions, right? So again, if you have to take anything away from this, it's just that Kubeflow enables you to go from AI science to AI engineering. And if you don't remember anything from there, just search Kubeflow. You'll find a ton of information on the web. I also listed some of the links in the PDF that you'll get. So there is a lot of action items for the community that is working on Kubeflow, right? As I said, it's a very new project. It's still not 1.0. So we want to improve the reliability and usability at scale, right? When there is large number of containers, right? We want to add monitoring into the system. There is fair bit of monitoring that capability in the Kubernetes ecosystem, but we want to integrate it with Kubeflow as well. There is already integration with Istio for a lot of the monitoring ability. We want to improve benchmarking, the KubeBench repo that I was talking about. And there is a lot of example solutions that we want to hand out so that any community of ML users can pick up a sample example and then can work through it, right? There are already quite a few examples, but as we speak, there might be more that are getting added. And then new features, AutoML, which is, if you are aware of neural networks are nothing but a particular graph of getting the data in and then training and getting out some parameters. But generating that graph is usually a manual process, but AutoML is the field in which says, okay, it will auto-generate that graph for you, which is best suited, right? So all these advanced features are also coming into Kubeflow. So I have some action items for you as well, which is, you might want to visit the Google booth where they are also showing basically the same demo as the bolts classification. So we have been working very closely with them for the demo. So they are probably showing the demo as well. And I would urge everybody to go and look at kubeflow.org. That's the website. From there, you will get the access to the code. You will get access to beginner's guide, examples, a lot of other things. You can directly start contributing with the community. We have weekly meetings, just like most open source players. We also have our own homegrown CPSG or Cisco generated workflow, which we term as KF Lab, which is Kubeflow Lab. We have been using it internally to train some of our engineers. And what we have found that most engineers can go through the machine learning part very quickly, but they cannot have a running solution that is accessible over the internet or something, even if you give them a week or 10 days. So the machine learning solution comes up in under a day, but the entire solution takes weeks to get out. So we are training our own engineers to see how better we can use Kubeflow even inside Cisco. You can send me emails. I urge you very much to send me emails about your use cases. What is your ML scenario that you want to work out? Is your ML scenario simple enough that you don't really need Kubeflow? Is it difficult enough? What are your pain points? Please do send me email. And what we'll do post Cisco Live is we will collect all the emails, all the information in the emails. And if you want it to be anonymous, please mention. We'll keep it anonymous. We will have a blog on Cisco's website, which will kind of highlight all the pain points. And then this will also go to the Kubeflow product management community so that we prioritize those issues, right? Because right now the Kubeflow community is looking for real customers who are willing to use this and are willing to share with us what are the important pain points that they want resolved first, right? And I would end this session by making a plea to you that you would get the chance to give a session feedback. So please take your time to give a session feedback. This is my first Cisco Live. I've never been in a Cisco Live, so feedbacks are very important. We take it very seriously, and I have a session in Thursday, which is not the same. It'll be a similar session, so I might be able to even include some of your feedback by Thursday as well. So I urge you to give your feedback, good, bad, whatever you found in this. Um, that's about it, and I can take any more questions. I will hang around after the session as well, so I can take more questions if you want. Yeah, please.
Any plans to integrate it with CCP?
Oh, yes.
I'm not working for Cisco, but it's
So the question was, is there any plan of Kubeflow integration with CCP? As a matter of fact, yes. And today there was a CCP presentation where we talked about Kubeflow, but not integrated directly with with CCP because we just couldn't get the demo working before Cisco Live. So there are some UI issues and all, but it is very much in plan there because when it comes out from within Cisco, it can run either on CCP or you can have your vanilla Kubernetes on top of, say, your UCS boxes, and it should run there as well. So CCP integration is very much on the plans. By Cisco Live US, we will definitely have announced it or would have demos about it. We are probably also going to do stuff for Google Next, which is before Cisco Live. Any other questions? Technical questions? Anything about Kubeflow, who all are involved, which are the companies involved. We see a lot of involvement from, so Google and Cisco are, I would say, the primary code contributors right now. But there is a lot of contribution from IBM. There's a lot of companies from China who actually contribute because, as you know, there's a ton of companies working on AI ML in China. So a lot of contribution from there. I'll keep my business cards here. If you want to pick up any and send me email, that is great. I will try my best to respond to you as quickly as possible. Thank you.